In the last video, you have seen that how we can apply L'Hopital rule in the limit questions. Now, if in a limit question, you get 0 into infinity form, which is an indeterminate form. So, how you will solve that question? Let's say there is a limit question, x is approaching to a, and there is some function f of x into g of x. When you directly apply the limit, you get 0 into infinity. Whenever this happens, what you do is you go back to your question and modify your question in some way such that when you again apply the limit as x is approaching to a, you get either 0 by 0 or infinity by infinity form. Because if you are able to rewrite or modify your function on which the limit is being applied, and you get by applying the limit 0 by 0 or infinity by infinity, then you can apply the L'Hopital rule and then simplify your expression and then apply the limit. So let's try to understand this by solving a problem. We have a question where we have to apply the limit x is approaching to 0 plus x into ln x. As every question of limit begins by directly applying the limit, here x is approaching to 0, so we will apply this limit x into ln x. Now when we directly apply this limit, we get 0 because x is approaching to 0 into ln 0, which is 0 into ln 0 is infinity. You got 0 into infinity form by directly applying this limit, which was x approaching to 0. So what you do is you go back to your limit question and rewrite your expression in a way that when you again apply the limit on that rewritten expression, you get either 0 by 0 form or infinity by infinity form. So how can I rewrite this expression? I'm going to keep ln x here as it is, but I'm going to bring x down. When I do that, I can write it as x to power minus 1. When x was here, its power was 1. But now I have brought it down. I have not changed anything because if I bring this x to power minus 1 back up, it will still be the same expression. But now after rewriting it, I will apply the limit and see what happens. ln 0 divided by 0 to power minus 1. We know that ln 0 is infinity, so in numerator we will write infinity. Now we have to find 0 to power minus 1. 0 to power minus 1 could be written as 1 over 0 to power 1, which is 1 over 0, and 1 over 0 is infinity. So 0 to power minus 1 is actually infinity. So see, after rewriting your expression, when we apply the limit, we get infinity by infinity. And we know that whenever we get 0 by 0 or infinity by infinity, we can apply the L'Hopital rule. So now we can apply the L'Hopital rule here, which gives us limit x approaches to 0 plus derivative of numerator divided by derivative of denominator separately. Derivative of ln x is 1 over x divided by derivative of x to power minus 1. By power rule of derivative, it is minus 1 x minus 1 minus 1. Now that we have applied the L'Hopital rule, we are going to simplify this expression, which is 1 over x divided by minus 1 into x to power minus 2. We will continue to simplify. X is approaching to 0 plus 1 over x over minus 1 over x square. Simplifying it further, 1 over x, we bring this denominator 1 over x square up, it becomes x square over minus 1. Simplify, we get minus x. After simplifying to its very last step, we will apply the limit x is approaching to 0, so here we have minus 0 is just 0, and we are done here. So this is how we solve this type of question where we get 0 into infinity form. Rewrite your expression such that when you have rewritten your expression and you apply the limit, you get infinity by infinity or 0 by 0 form, and then apply the L'Hopital rules, simplify your expression and find your answer.